Alright, this one's a little bit trickier because our sigma y is bigger than our sigma x. But let's plot this on our element first. So I have positive outwards. I don't have anything in the x direction. And I have this positive tau. My sigma y is up. So go 1, 2, 3, 4, 5, 6, and up 4. 1, 2, 3, 4. My sigma x is down. It's at 0, so it's 1, 2, 3, 4. Okay, so some things to notice here is that since our sigma x is lower, it's on the opposite side of the circle. Let me just draw the rest of the circle real quick. The thing that messes most people up is they always think sigma x is the bigger one, and that's not the case. So when I'm looking for my principal angle, I don't want to go down. That's not right. I want to go for my sigma x, which was at 0, right here. Then I measure to my principal stress element. So that's my principal angle. And that's a very common mistake, so don't make that one. Okay, let's put this one on this element. One thing to notice is that this is a negative shear. So I have negative shear goes away from this corner. All 4 arrows switch direction, but it's still the same magnitude, still 3 ksi. I just switched the direction. It also changed the way our Mohr circle looks. So the thing to remember is that when you have a negative tau, that means that sigma x is up and sigma y is down or below the axis. So sigma x is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and now I go up 3, 1, 2, 3. So this is, remember that tau is negative here. So I could plot this point to be 10 ksi, negative 3 ksi. And sigma y is always the opposite, opposite distance on the tau axis. So I'm at 1, 2, and I go down 3, 1, 2, 3. So if I were to plot this, if I were to write this point out, I'd say 2 ksi, 3 ksi. Alright, now I can connect those lines, and let's compare. This is the first problem, and here's the last problem I did. They had the same normal stresses. My sigma x and sigma y were the same, but my shear stress, although they were both 3 ksi, one was positive, one was negative. And you could tell they're relatively the same positions, but it's a flipped image. It was rotated about the sigma axis. So ended up being mirror images this way too, but that just comes from having switching the sign of your tau. So keep that in mind. Some other things to note here is I can calculate this, my principal angle, pretty easy. I don't even need the formula necessarily. Conveniently, again, I have a 3, 4, 5 triangle, and I'll draw where it is right here. I can calculate this angle using the 3, 4, 5 triangle, and this is just a 90-degree angle. So without even having to use the formula, I can just calculate this angle, add 90, divide that new angle by 2 to get my principal angle, which is 63.43 degrees. Now that means my stresses on here are the greatest and the least normal stress. I could calculate that pretty easily without any formulas as well. Since this is a 3, 4, 5 triangle, I know my radius is 5, and I know my average is 3, right between 0 and 6. So 3 plus 5 is 8. So this is 8 ksi. I have 3 minus 5 gives me negative 2. Notice I didn't put the negative on here. All I did was switch my arrows to go inward. That's how I indicate my negative sign on my actual diagram here. So to recap, I was able to easily find my principal angle and find my principal stresses. Just looking at Mohr Circle, I didn't require any formulas. And I drew it at that angle and put those stresses on the element.